Here's a video on making a tooth deck for a metal mouthpiece that's missing one. This is a Runyon Quantum. They're no longer made, but these were sold both with and without tooth decks. Your client sent me one without one. I own one myself with one, so I have a good reference to go by here. I've also made a tooth deck previously for a Brillhart Level Air, and I use a 3D printer for this. I have made them out of acrylic, casting them and shaping them, but this is just a new way of doing it. It probably takes more time to do it this way, but once you figure it out, then you have an object you can use for others. We first start out by taking a lot of measurements, and and I made a sketch here, and I took a bunch of key measurements off of this mouthpiece. I'm going to be working in metric. Okay, so I get like the width of the mouthpiece here, which gives me the diameter. Then this drop here, you got to decide whether you want to measure diagonally or straight across. You do have to do some trigonometry and to get all this to work in the CAD system, but there's a drop here, and that is shorter than the radius, so this point here is above the center line. Things that I've observed on here are that you've got a flat angled back piece here. This bottom part here is curved, okay, and then when you get to you have to also model the top round and the duckbill part. The duckbill is curved in this direction and this direction. So for some of the measurements, it's handy to have a set of radius gauges. For instance, on this one I got easy to measure the diameter, but you can use these to kind of verify things. The 7/16, this is not metric, it's 7/16 is too large, and the next down, a 32nd smaller, is a little too small, so it's in between those two. And this is handy, but it's limited range, mostly smaller sizes. When you get up to something like, what is this radius here, you have to look around for objects that you may have in around the house. In this case, like a coffee can lid. Whoops, boink. I held that up there, and it was real close to that, or roll of tape, and you can measure these diameters and get a starting point at least for those. What else? The angle. You can just guesstimate, or you get one of these gizmos, but these are hard to measure objects, tiny objects, to get an accurate angle, but it's better than nothing, and you have to figure out which scale you're on. So, I thought this was around 127 degrees. And then you're just going to have to make some and adjust the dimensions at the end. So there's a starting point. Now I'll show you what I'm going to be using for modeling is a program called OpenSCAD that I like. I've tried using FreeCAD. I've designed mouthpieces in both systems. I prefer this. There's pros and cons of both. So this is more of a programming language. It gives me what I want, but it isn't mouse driven. It's code driven, as I'll kind of demonstrate. Now what I've done is I've created a bunch of variables in here. There's a lot of tutorials on YouTube of getting started in this. And then there's also a cheat sheet that you bring up that's online that has all the commands on there. And then you can click on these commands and bring up, individual detail about them. And learn a little at a time. A few basic commands take you a long way. So I start out with a $FN almost every thing. That, and what that does, according to the cheat sheet, is it defines the number of fragments that are in a circle. Their default is a little lower than I like, so you got to pick something, closer to 100 to get some nice looking surfaces. Okay, so like I said, anything with a double slash is a comment. So here I define the rear width across the mouthpiece. Then I do the front width. Then I calculate the rear radius. So they're all documented on here. Angle 127.5 is my starting, my deck angle there. And then, like I said, it ignores everything after the double slash. So they just, comment on what your variables are to try to, so you can remember it, because there's no graphical way of showing it on here. So now the code, you don't have to indent it, but it makes it easier to see a lot of commands that may be multi-line long. So I do that. I also try not to put too many commands on one line. It's easier to read. And as I build the code, you'll see how I do it. So we start out with what I call the total deck material is going to be made out of a cylinder. So, also I have it made the code set in my preferences so that I have to hit preview for it to generate. So there's my starting cylindrical material. And in OpenSCAD, it puts everything near the origin. Hit Shift key, and you can use your mouse to rotate it around. So it puts everything at the origin. And in my case, my origin, I decided to choose the center of the top of the mouthpiece at this V as the origin. So this cylinder it needs to be repositioned back a little bit. And that's what the next command, where are we? Okay, cylinder in the black. That's all we have done now is this cylinder. Now above it is where I move it. The translate is a command that moves things in the X, Y, and Z direction. And you can see your axis is always showing here. So we don't want to do anything in the X. We do want to go move it both in the X and Y direction. So there it is. You have to drop it down a little, and then we had to move it back some. Okay. Then we start chopping away at it. The first thing I do is I position a cube-shaped material right here, line 37. Boom, boom. I created a cube. Okay. I'm going to put a number sign. We'll kind of make it red translucent so you can see it. And that's where it default draws it with one corner at the XYZ origin. Okay, and what I want to do is position this near the back to cut off the angled back of the tooth deck. So above it, I have a translate command. That could be on a separate line. So here's a translate. I move the cube XYZ, and then I rotate it. So both of those will now happen. Okay, now you see if I took away the rotate, it would be like that. So it rotates about the origin. So got to make sure you rotate things the way you want near the origin, and then move it where you want it on some cases. So yeah, we do that. Okay, and then to subtract it, you use something called a difference command. Okay, so that's when I first started. I had the difference command right above this line, but I later added stuff. Well, actually, it is right above everything. Here we have the total, the cylinder and the cube, and you want to subtract one from the other. So let me take this difference out. So that open bracket starts the command, and down here is a closed bracket that ends the command. You see everything is indented. This is a wraparound. But everything is indented all the way up to this point, and that's one kind of thought, and it slices away the cube portion, behind that cylinder. So that's one. Now the next thing I'm going to do is draw a cylinder to scoop out the bottom. So again, it puts it kind of right on the origin. It's a big cylinder, but the scoop on the bottom is almost flat, so it was a very large diameter. So now I want to position that. So there it is, positioned underneath the tooth deck, and we want all that material to go away that's underneath it. So we go up, and there's another difference command up here that I've commented out. So bring that into play, and beginning bracket, end bracket. And this is indented so that this is, you know, it's the previous difference minus the new cylinder. Okay, so that's chopped away. One more easy one now is the tip curve. So the next thing I do is I draw a cylinder that is for the tip curve. Again, I'll highlight that with a number sign. Zoom out. And I have to position it where it actually, you know, it's already been rotated 90 degrees. Normally, when you draw it, it would be like this. So I already had a rotate command of 90 degrees about the x-axis and moved it down. Okay, and now I want to translate it to the beginning. Okay, that's positioned. Now, in this case, I can't use a difference. I use what's called an intersection command, and it keeps the material that's common to both objects, and it throws away this part on the outside. So up here's an intersection, boom, boom, and the end bracket for that is down here. Okay, and then let's get rid of this number sign. Okay, now the last piece is the top, the duckbill, the beak area. And as I said before, that's complicated because it's curving in two directions, like a saddle. So, let's see what else we got going on. So the next thing, the tip curve, for some reason I had a bunch of spaces in here. I can get rid of them. We needed to draw, okay, I need what's called a rotate extrude to create kind of a donut shape. To do that, you actually have to start by drawing a two-dimensional object, in this case a cylinder, okay, and then position that away from this, it's in the XY plane, but you want to position it away from the axis, and then it's going to rotate about that axis. And I had to, you know, you'll have to use the, get into your help area, your cheat sheet, and go down for where is it? You click on rotate extrude, and it'll bring up, you know, it'll show you kind of the syntax of how you have to lay it out, you know, or the method. So here I'm creating one of these objects because the inside of that is a shape that's going to be taken away to create the bite plate. So, all right, so I've drawn that, and now I have to rotate it, rotate extrude, which is start, end, and I've only taken a 40-degree angle of it. Like, you know, if I left it at 360, it'd be hard for you to see every. The default is 360, okay, and then, you know, you can kind of see everything there, but after I reposition it, here's a translate command to reposition it, boom, boom. that'll work there. Put a number sign in front of that. Okay, so there it is, but it's really tough to kind of see what we're doing. At least it's transparent. So if I shorten that from 360 to 40 degrees and kind of rotate it a little bit, you'll see what we're actually doing here. A little easier. Okay, let's see, that's the segment that we're removing off the top, and it creates a curve in 2 directions. So, and this is just another difference command. Okay. Oops. Again, I don't know why I had so many, must have been leaning on the keyboard and created a bunch of spaces. Go up to the other part of the difference, and that should take it away. And that's a basic, shape. And I've refined this to get all my numbers right and the way it looks like. One thing I wanted to show you, for help with troubleshooting and understanding code, sometimes it's helpful to plot a point. For instance, I had the duck bill area. I used to have it at 50 instead of 59. It was drawn way out like this, and that's not the shape I wanted. I wanted it to pass through a certain point, so I actually plotted that point. You can go down, and here's a scratch area where I have a bunch of stuff I commented out, but there are a couple of these are a couple lines here where I actually drew a sphere and positioned it where I wanted it, positioned 2 of them. So right here, we have one positioned at the tip along the center line, and one positioned back here where I wanted the top of this to go through. And I tried to work out the geometry, the calculations to figure out a radius from these 2 points. That's why I have them here. But I couldn't get it to work. So I ended up doing just trial and error after, and I may go back and visit it, but I got tired of it. So if I go back here, that's all I need to do is adjust my 50, keep adding numbers to it to make the radius longer, because the way I laid it out, it's going to pass through this point, but it wasn't passing through that point. So I played with this until I got it to 59, and then it reasonably went right through the top there. So that's helpful for, to working with this. The other thing that's helpful is if you're trying to figure out if it's calculating numbers correctly, you can use an echo command. And let's say this echo will display these 3 calculations here, duck Z, duck Y, and DR, and it'll put it in this console area. So when you hit print, you got to go looking for 3 numbers. There it is, the echo. And there's ways you can label these and space above and below them and things of that sort. But I then compare these to some hand calculations or whatever, and it helps with some troubleshooting when you're trying to figure out why something's working or not working. Okay, you can, there's no built-in way to do fillets and rounds. That's one thing that FreeCAD and other CAD programs do easier. You have to, it has something called a Minkowski that I've used, but it's very slow. It's not real easy to set up. It's not too difficult, but it is definitely slow. And I've used it when I've designed mouthpieces, but I'm just going to sand the edges that I want sanded. So there we have it. So after you get something you like, you then hit the render, and basically, it now creates what the geometry really is. Sometimes the preview is not as accurate as the render, but you got to create the render. Then you create an STL file, and you store that where you can find it. Okay, and then when you get ready to work with a 3D printer, you bring up a slicer. In this case, Cura is very popular. Then you bring your STL file into it, and it'll look like this, you know, when it comes in. And you know, I tried positioning it flat on this bottom, but this angle's pretty steep. I decided, you know, when I did a Brill Heart, I was able to print it right on the bottom. But since this is a steeper angle, I just positioned it straight up, and I'm going to fill this in with, it can generate supports. So after you slice it, you know, slicer determines all the you know, the code that you need for the 3D printer. You can make it hollow or solid. In this case, we're making it solid. You know, it's kind of small, thin, I mean. And then, you know, this blue down here is waste material that's only used to, you know, create the object. Okay. Then what comes out, it looks like this. Okay, it still has a little bit of waste material on there, which sometimes is tricky to get off. Put this back down and break out some tools. There we go. So pop that off, and you know, have to clean it up a little bit. Sometimes there's some ridges, some seams that you know, might not lay flat. I'll do more of this after I turn the camera off. This bottom surface will need to get flattened out a little bit. You know, like I said, I have to sand the edges, round the corners a little, but this should work on there pretty good. It looks like that angle wants to be a little more than I have. I may just, you know, since I'm so close, I'll just file back, you know, this area until it fits. I think I have everything else nailed pretty good, because this is like the third, fourth one that I've done, and I'll be able to kind of shape it from here and get that all to work. Okay, this is how it was clamped up after putting some two-part epoxy on there. I used Loctite. Got to clean off some of the glue residue. I used some rough sandpaper on the plating underneath there, scuff it up a little bit to get a good grip. So that looks good to go.